they do division or quotient separately because it's a little bit more complicated. And again, they have the nice notation and the not nice notation. So nice notation looks like this or like this. And not nice notation can look like this. So if we had an example of not nice notation, you might have f divided by g of 2. Or they could write it, I've seen it like this as not nice notation. I would suggest anytime that you have not nice notation, I prefer this one, change it to f of 2 divided by g of 2, which in this case, you know that f of 2 is 2, g of 2 is negative 1. That simplifies to negative 2, and sure enough, on your green graph, you have 2, negative 2. So just like adding, subtracting, multiplying, when you divide the y-coordinates, your x-coordinate stays the same. And just like adding, subtracting, multiplying, dividing, you have not nice notation and nice notation. The difference for dividing is that your domain, right, domain of f of x was bigger than 2, domain of g of x, domain of g of x was everything. In adding and subtracting, you can only add, subtract, or multiply where both domains are. That's the same for dividing, but in dividing, you also have to look, where is it that your bottom function, in this case, g of x, the blue one, is in your denominator. Where is your function in your denominator also equal to 0? Because you're not allowed to divide by 0. So your domain for your green graph will be x is bigger than or equal to negative 2, just like all the other ones, but you have an addition that x can't equal, because we have an asymptote here, at 1. So the domain for division 1 adds in non-permissible values. That's why division is done separately. It's not that much harder, but it's just one extra thing you have to think about for division. It's still, where do the two domains overlap? Okay, that's important, but you also have to look for non-permissible values. So when you look at our example for dividing, okay, use f of x as square root of x and g of x equals x minus 2. Again, I'll color code these, f of x in blue, g of x in green. So part A, for f of x, what's our domain? You can't take the square root of a negative, so x is bigger than or equal to 0. For g of x, what's our domain? It's a straight line. Again, you might want to, above here, draw pictures of both of these. Now in part B, again, we've got write an explicit equation. So q of x will equal, in an explicit equation, on the right-hand side, you have only x's, not function notation. So instead of f of x, in our numerator, we'll write square root of x. Instead of g of x, in our denominator, we'll write x minus 2. And at this point, looking at this question, right away I'm going to note, oops, close to note it. I'm going to note my non-permissible value that x can't equal 2. because if x is equal to 2, I would divide by 0. Now we want to find the domain and range. The domain is going to be the easy part. Okay? It has to be the overlap of the domains above, so we can only take when x is bigger than or equal to 0. We also have to consider our non-permissible value. X can't equal 2. So that's what's added with division questions. You have to think about the non-permissible value as well. And just like before, the best way to find out the range is to draw the graph. Unfortunately, the equation that we have, square root of x over x minus 2, is not one that we've graphed in any of our units. We've done rational equations, but we never did a square root on the top in our rational equations unit. So the only way we can do this as a graph is to take our first graph, which was a square root graph, 0, 0, 1, 1, 4, 2, and so on, and our second graph, and try to put them together on our purple graph. Okay? What would happen if you did 0 divided by negative 2? You get 0. What would happen if you took 1 divided by negative 1? You get negative 1. What do we know happens at positive 2? We have a non-permissible value. So we would have an asymptote at x equals 2. I'm not going to plug in 3 because it's not a nice value on my square root, but I have 4. I'll plug in 4. 4, 2, and 4, 2. So at 2 divided by 2, 4, 1. We know that our domain is just when x is bigger than or equal to 0. Are you okay with this part going here? We can steal a little bit from our rationals unit in that something from grade 11 math. Are you okay with the square root of x being written as an exponent as x to the half? You remember doing that in grade 11? Okay? If I had rational equations and I have an x to the half in my numerator and an x to the 1 in my denominator, can you see that the degree is bigger in my denominator? In our rational functions unit, that was chapter 2, what kind of asymptote did we have if the degree was bigger in our denominator? Whew. This is one of the reasons I like ending with this chapter, because it does cause us to review a lot of our other chapters. If the degree was bigger in our denominator, we had an asymptote at y equals 0. And if that's the case, this part of your graph looks like this. The reason we were graphing this is so that we could see if we could figure out what our range is. And it's not an easy one even after graphing it to see the range. Okay? You might be tempted to say it's everything except for 0. Can you see yourself saying that? It's everything except for 0 because there's an asymptote at 0. But can you see that you have this point 0, 0? So 0 is actually included even though there's an asymptote there. And so all of that work just to say that the range is everything. All right, questions for practice 6, 13, and 16.